Welcome to another presentation on network analysis subject. And in this today's presentation, I am going to explain about the supernode concept to analyze the given circuit, how the supernode concept will be applied, and thereby how the voltages can be evaluated. Let us see for this another simple circuit where this particular point will be considered as node 1 and this particular point will be considered as node 2, and also assume that V1 is the voltage at node 1 and V2 is the voltage at node 2. Now for this problem, our question is to find out V1 and V2. What is V1 value and then what is V2 value using this supernode concept. So the very important point to remember while solving using this supernode is that what is a supernode actually? Supernode is nothing but sometimes in most of the electrical network circuits, it is quite easy to analyze the given circuit if a single node or for a simple circuit where we have one voltage source and 2 3 resistances will be given in the circuit. But let us consider this particular circuit where something by using the nodal analysis we cannot easily solve this question directly. By using nodal analysis it will be little bit complex to solve this question. That is why we go for the next extension to the nodal analysis is nothing but supernode concept or supernode analysis. What is a supernode? How a supernode can be considered for the given circuit, that is very important, right? Once if we identify the supernode, then it is very easy to evaluate the corresponding voltages and to find out the solution for the given problem. Clear? So for this given simple circuit, the supernode is nothing but the nodes. Okay, the nodes are the different nodes which will have a common voltage source in between two nodes. Okay, suppose if there is any voltage source is available as a common between two nodes, then that particular nodes can be treated as supernode, right? So as we have already discussed in the previous example, okay, so there must be a common point will be there, that is ground node normally, that is at zero potential definitely. And whereas if you consider these two nodes, these are called as non-reference nodes. Remember that these are called as non-reference nodes. That is very very important. Node 1 and node 2, they are called as non-reference nodes, whereas the node with respect to this ground point is called as the reference nodes. This is called as a reference node, right? Good. Now the super node is nothing but the nodes which will have a voltage source as a common between those two nodes, that can be treated as a super node, right? So between any two nodes there must be a voltage source, then those two nodes treated as a common node or a super node. So how to solve to find out V1, to find out V1 value and V2 value? That is our question in this problem, right? To solve by using this super node, very simple fundamental thing is we have to remove this voltage source. Actually, we have to remove this voltage source from these two nodes. We have to disconnect first. Okay, that is the first step that we have to do. So upon disconnecting this particular voltage source, obviously the resistor, 10 ohm resistor, is also connected with respect to this voltage source or across this voltage source. As we are removing this voltage source, automatically the 10 ohm resistor will also get disconnected. Therefore this total part, this total, I mean 10 2 volts, I mean voltage source, as well as 10 ohm resistor, both will be disconnected from here. Once they will disconnected from here, okay, then your new circuit will becomes like this. Just I am removing these two part, and just I am keeping the rest of the circuit as it is, right? Now this is the portion, right? Once upon disconnecting that particular voltage source along with that resistor, then it will be the circuit. Actually you can show as a dotted line. You have to, you can put there as a dotted line, no problem. Just because to know that the voltage, the common voltage source between these two nodes is disconnected, like that. To understand, to remember that point, just you have to, I mean, indicate with the dotted lines, right? Now that is the first step we have to do. Now as a second step, what we have to do, for this available resistors from this particular, because it is a node, we are consider this as a node. Therefore from this node to the ground point or ground node, the resistor is connected. Therefore assume that some current I is flowing through that, that is called as I1. Similarly, with respect to the second node, and some current flows through this 4 ohm resistor, consider it as a I2. I2, consider it as a I2, because you can see it as a one loop. Actually you can able to see it as a loop. Therefore from this node through this resistor, assume that I1 current is flowing, as well as as it is a second loop, assume that I2 current flowing through this resistor. Now 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 we have to apply the KCL, Kirchhoff current law, because in the supernode analysis, both KCL and then KVL will be applied for the given circuit to solve the voltage V1 and then V2, right? Both KCL as well as KVL will be applied. Now, after disconnecting this voltage source along with that resistor, now the step one is, now the step one, or the first step is removing that voltage source. Now step two is, for this entire circuit, for this entire circuit, we have to apply the KCL. How the KCL will be applied? So just I am erasing this part and I will write the equation here. So if you see this particular, for this whole circuit we have to apply the KCL. Upon the application of the KCL, now I can write a complete KCL equation as like this. So it is 2 ampere current is equal to, right, it is entering current at a node, because as the voltage source is disconnected from here, now with respect to this V1 and V2, nothing but with respect to this node 1 and node 2, now you can treat the entire this part as a single node or a common node. Assume that the single node is there. Therefore at this particular node, with respect to this common node, 2 ampere current is entering, and from this point I1 is going out, I2 is going out, 7 ampere is also going out. Therefore how I can write the input current 2 ampere is equal to I1, right, plus I2 plus 7 ampere. Can I write like this? Can I write like this? This is according to KCL. What is the KCL? So the input current or the current entering at a node is equal to sum of the leaving current from that node. Therefore I1, I2, 7 amperes are leaving from that common node. Therefore I1 plus I2 plus 7 is equal to input current 2 ampere. Clear? This is the first equation that we have to consider. Now Now we have to write the expression for what is I1, what is I2. I1 can be written as, here the nodal voltage is V1, therefore I1 is equal to V1 minus 0. Therefore this implies you can write it as V1 minus 0 by it is 2 ohm plus what is your I2? I2 is equal to V2 minus 0, V2 minus 0 by it is 4 ohms plus 7. This is 2 is equal to. Now I can erase this circuit because I do not need this circuit now for simplifying the expressions, because already I got the equations which I require to solve this. Therefore, this implies you can write 2 is equal to V1 minus 0 by 2 is nothing but V1 by 2 plus V2 minus 0 nothing but V2 by 4 and it is 7. And furtherly what you can write, it is 2 is equal to, right, otherwise this plus 7 you can take to the left side, that is 2 minus 7, then what you will get, it is V1 by 2 plus V2 by 4 on the right side. Take the LCM of for these two, then obviously it is 2 4, then 2 times are nothing but 2V1 plus 4 into 1 times of, therefore it is V2. This is equal to 2 minus 7, it is nothing but minus 5, it is 2V1 plus V2 by 4. Upon taking the cross multiplication, you will get minus 20 is equal to 2V1 plus V2, right? This is one expression you can take. Maybe equation number 2. Maybe equation number 2. Right? Equation number 2. Now, again from the circuit, actually, if you can see from the circuit, you can write now the KVL, right? This is with respect to the KCL actually. Now, the KVL will also applied to that particular circuit. So, between that common 2 points, nothing but V1 and then between V2, we have the voltage source actually like this. Is it not? Refer the circuit actually. So it is 2 volts as per the circuit, and across the resistor is also there. But remember that the resistor will not, give any impact on this. So if you see that particular circuit by using that KVL, you can write this expression V2 minus V1 is equal to 2 volt. Can I write like this? This is with respect to the KVL. This is our next equation. Therefore, what I mean to say is that after identifying the supernode, remove that supernode, take it as a common. Now for the whole circuit, apply the KCL. By applying the KCL, you will get one equation in terms of V1 and V2. So give it as some equation number, and after that between that common nodes there will be definitely voltage source. Therefore you can write the in terms by using the KVL, you can write the another equation in terms of V1 V2, and by substituting or otherwise from the equation 2 and 3 you definitely can bring the values for V1 and V2. Therefore from this equation number 3, what I can write, V2 is equal to, if you bring this V1 to the right side, it is definitely 2 plus V1. Am I correct? It is 2 plus V1. Give it as equation number 4. Now substitute this V2 value, that is V2 is equal to 2 plus V1 into equation number 2. Then obviously what you will get, so substitute equation 4 in equation 2, 4 in 2, okay? Then what you will get actually, minus 20 is equal to, it is 2V1, right, plus V2. What is your V2? 2 plus V1. Therefore, this implies furtherly 2V1, V1, it is 3V1, is it not? Plus 2, right? And bring that 2 to the left side, definitely what you will get? What you will get? So if you bring that 2 to the left side, definitely it will be plus 2. If you bring this, it is minus 22 is equal to 2V1, 3V1. Therefore, from this implies, from this V1 is equal to minus 22 by 3, it is something minus 7.5 uh, 3 volts. This is what your V1 actually, right? This is the answer for V1. And similarly, if you substitute this V1 value, that is minus 7.33 here or here also from this V2, substitute this V1 here, then from this you will get, from fourth equation you will get your V2 is equal to 2. What is V1 value? Minus 7.33, right? And therefore it gives minus 5.33 volts. This is what your V2, right? Both we got the V1 value as well as V2 value. This is our answer. Therefore, this is what the procedure to solve for any given question, problem or question by using the supernode concept. I hope you understood very well, and we will do some more examples on this concept in our subsequent presentations. Thank you.